Okay, so let's take a look at your homework questions, page 191, number 24. A 1975 kilogram car is parked at the top of a steep 42-meter long hill. Okay, when it tells you the hill is 42 meters long, it means the length of the hill this way. Okay, at an angle of 15 degrees. And it says the car starts rolling down the hill. How fast will it be going when it reaches the bottom? So it starts rolling down the hill, so VI is 0. How fast will it be going? It's asking for VF. It's told you the delta D. You need the A. So to get the A, you need to do sum of the forces. So there'll be an FG acting straight down. That'll have components FGY into the incline and FGX going down the incline. Fn will be going up, and friction will be acting backward if the car is rolling down the hill. Okay, if you look at your components, FGY is the adjacent side, so it should be FG cos theta. Or if you want, it should be MG cos theta. I wouldn't find the value if I were you. I'd leave it like that. And FGX should be FG sine theta. It's the opposite side. So FGX should be equal to MG sine theta. And again, I wouldn't find the value. I think I need to come back. It says neglect friction. There is no friction, so we don't even care about the FGX because we don't need the normal force. So you're only going to do some of the forces in the x direction. And the only force in the x direction, if there is no friction, is FGX, which is what's making it roll down the incline because there's no friction. So it'll be FGX is equal to MAX. And we just finished saying FGX is MG sine theta. And that's equal to MAX. The m's will cancel. That's why I didn't want you to do anything before by multiplying through. And so we're just left with 9.81 meters per second squared times the sine of 15. And we get an AX of 2.539 meters per second squared. And now that we have our AX, the question wants to know what's the final velocity. So we have a delta D, a VI, an A, and we want a VF. So VF squared is equal to VI squared plus 2A delta D. VI is 0. VF squared is equal to 2 times 2.539 meters per second squared. And it said the hill was 42 meters long. Remember, that'll be VF. You need to take the square root, and when you do, you get 14.60 meters per second. Number 24 is done. Number 25, starting from rest, a cyclist coasts down. So we're on an incline again. Coasts down a starting ramp of a professional biking track. The ramp has minimum legal dimensions of 1.5 meters high and 12 meters long. So again, this is your 12 meters. From the 1.5 and the 12, you could find the angle. Sine theta will be equal to 1.5 meters over 12 meters. So theta will be equal to 7.181 degrees. Okay, we're putting our bicyclist on this track. Here's my FG acting straight down, my FGY going into the incline, my FGX pulling them down the incline, my normal force acting up. And in the first part, it says ignore friction, find the acceleration of the bicyclist. So if we're ignoring friction, we don't have to do the y direction, just the x direction. And the only thing that's acting on the incline in the x direction is FGX. So FGX is going to equal MAX. FGX, we found it right up there. It's MG sine theta is equal to MAX. So part A of this question is identical to the one before it. So AX is equal to 9.81 meters per second squared, sine of 7.181. And when you do this, you get an AX of 1.22625 meters per second squared, part A. Part B says find the acceleration of the cyclist if all the sources of friction yield an effective coefficient of 0.11. So now there's friction acting and it'll be up the incline because you're sliding down, and the coefficient is 0.11. So now you need to do sum of the forces in the y direction, which will be 0. It'll be Fn going up minus Fgy going down. So Fn will equal Fgy. It's the adjacent side. That should be mg cos theta. Okay? So I'm just going to go over here to keep going. So now I'm going to do sum of the forces in the x with friction in this time. So it'll be Fgx going down the incline, which is positive, minus friction, which is acting up the incline, which is negative. Fgx is mg sine theta. Friction, of course, is mu Fn equal to max. And Fn is mg cos theta. So we have mg sine theta minus mu mg cos theta equals max. There's an m in every term, and so you can cancel it. And we're solving for a. So it's going to equal 9.81 meters per second squared sine of 7.181 minus 0.11 times 9.81 meters per second squared cos of 7.181. And you should get an AX of 0.1556 meters per second squared. Okay, there's a third part to the question that asks for the time it takes to reach the bottom of the ramp if the acceleration is what we said in B. So it starts from rest, so VI is 0. We have a delta D, we have an A, and you're looking for time. So delta D is equal to VI delta T. 1/2 A delta T squared. This goes to 0. So T squared is going to equal 2 delta D over A. So 2 times 12 meters divided by 0.1556 meters per second squared. Remember, this will be T squared. You will then have to take the square root, and when you do, you get 12.42. 12.42 seconds to go down the ramp. To go down 12 meters, you're not really zooming on this bike. Number 16. A skier coasts down a 3.5 degree slope. So here's my slope. This angle is 3.5 degrees. Here's my skier. At a constant speed. Constant speed means AX is 0. Okay, so acting straight down will be my FG. Into the incline is my FGY. Down the incline is my FGX. Normal force acting up. Find the coefficient of kinetic friction between the skis and the snow. So friction would be acting backward if you're going down. So sum of the forces in the y direction. He's not moving in the y. It should be Fn minus Fgy equals 0. So Fn equals Fgy. If you look at the picture, that's the adjacent side. So it should be Fg cos theta, which means Fn is equal to mg cos theta. That was really an Fn. Okay? It didn't give you a mass, so you can't find it. Go to the sum of the forces in the x direction. And there are two. Fgx acting down the incline, friction acting up the incline. The skier's going down. Direction of motion is always positive, so Fgx will be positive, friction will be negative. Fgx is really going to be Fg sine theta. Friction is really going to be mu Fn is equal to max, which is 0. So mg sine theta is going to equal mu Fn, and Fn, mg sine theta, will equal mu mg cos theta.